Hello, Mr. Westwater here, about to take you through the June or May 2022 paper 1H. Right, on to question 1. Here are the first 5 terms of an arithmetic sequence. So we've got gaps of 4 each time. So if we think about the sequence 4n, that would generate 4, 8, 12, 16, 20. How do we get from 4n down to these numbers? We are subtracting 3 each time. So this sequence is 4n minus 3. Okay, and the nth term of another arithmetic sequence is 3n plus 5. So if I'm finding the first term, I would be substituting 1 where n is. If I'm finding the second term, I'm substituting 2 where n is. And if I'm finding the 2nth term, I am going to be substituting in 2m where that n is. Okay, so 3 times 2m is 6m, and then we still have that plus 5 afterwards. Okay, on to question 2. Here is a biased four-sided spinner. The table gives the probabilities that when the spinner is spun once, it will land on 1, or it will land on 3. So 1 has a probability of 0.6, 3 has a probability of 0.18. If we add those two together, that's 0.44 altogether. 0.26 add 0.18 is 0.44, which means we have 0.56 remaining. Okay. The probability that the spinner will land on 2 is equal to the probability that the spinner will land on 4. Okay, so if we divide this by 2, that gives us each of these probabilities, which is 0.28. So each of these has a probability of 0.28. Ravina is going to spin the spinner a number of times. She works out that an estimate for the number of times the spinner will land on 3 is 45. So what I'm actually going to do, and there's a few different ways we can do this, is use this probability of 0.18. Let's say she spun it x times. X times 0.18 is going to equal 45. Okay, so to find out how many times she spun it, we can do 45 divided by 0.18. So if I go 45 divided by 0.18, we get 250. Work out an estimate for the number of times the spinner will land on 4. Well, now all we need to do is just do 0.28 times that 250. And we get 70. Okay. On to question 3a. So find the highest common factor of 56 and 84. Show you're working clearly. So what I'm going to do, and you can either use your calculator using the fact button, so I'm going to hit equals and then do shift fact to say that 56 equals 2 cubed times 7, and I'm going to do the same thing with 84, but you can use a factor tree as well. So 2 squared times 3 times 7. And the highest common factor is we are looking for factors that they have in common. So they both have 7 in common, and they both got 2 squared. We would pick the lowest power of 2. So 2 squared times 7, which is 4 times 7, 28. Now if we're finding the lowest common multiple is slightly different, but the basis is the same. So 60 is 2 squared times 3 times 5. And 72, if we do shift fact, is 3 cubed times, 72 is 2 cubed times 3 squared. Now instead of just picking what they've got in common with the 2's and the 7's, it's anything that appears. So we've got 3 appearing twice, we've got 2 appearing 3 times, and we've got 5 appearing once. So the lowest common multiple is going to be 2 cubed times 3 squared times 5. which is basically 72 times 5, or 360. Okay, on to question 4. The diagram shows parts of 3 regular polygons meeting at a point. Polygon B, this one over here, has n sides. Okay, work out the value of n. So the first thing I'm going to do is work out x. There are 360 degrees around a point, so 7x add 3x add 8x must equal 360. Or 18x must equal 360, and divide both sides by 18, x is going to equal 20, which means 7x is going to be 140. Now, if I think about this, let's just take away everything else. Here's 140 degrees. If this is a regular polygon and each angle is 140, what I can do is I can work out the exterior angle, which is 40 degrees. And I know that all exterior angles have to sum to 360. So what I can do is say 360 divided by 40 is 9, and that must be the number of sides. Okay, because if each is 40, how many times does 40 go into 360? Okay, on to question 5. Expand and simplify. So n times n squared, n times plus 4, 4n, minus 6n, and then minus 24. The 4n minus 6n is minus 2n, leaving us with n squared minus 2n minus 24. And 5b, whenever I see a fraction in here, I always think, okay, let's multiply through by the denominator. So timesing through by 4, we have 8x minus 12 on the left-hand side equals 3x minus 5. Now grouping the x's together, I'll have 5x over on the left-hand side, minus 12 equals minus 5. And adding 12 to both sides, 5x will equal 7. Then dividing through by 5, x equals 7 over 5. Okay, or 1.4. On to question 6. Asher bought an apartment. The table gives information about the value of apartments in euros and the annual service charge band. So, in 2021, the value of Asher's apartment was 634,400 euros, and the value of Asher's apartment had increased by 4% from its value in 2020. So this is 1 year later, and if we have increased by 4%, it's really important. This is the multiplier we are going to be using. Even though we know, well, and what this question is saying is, has the annual service charge band for Asher's apartment changed? So I know it's going to be less in 2020, but I am still going to be using this 1.04. I'm not going to be using 0.96, as lots of people are tempted to do. So I'm saying, well, if I've got my value in 2020, again, let's call that x, times 1.04, this will equal 634,400. Okay, so x is going to be 634,400 over 1.04. Let's see what that is. 634,400 divided by 1.04, 610,000. Okay, so that is going to be in band B, and when it was 634,400, it was also in that band B. Okay, so has the annual service charge band changed for Asher's apartment? No. The band, and I'll put it in brackets, B, has not changed. I might even say 610,000 euros has become 634,400. just to give all the context and working as much as I can. Pam bought a boat. In each year after Pam bought the boat, the value of the boat depreciated by 15%. So again, before I read anything more, if it depreciates, then I'm timesing by 0.85. Okay, 1 minus 15%. Work out the total percentage by which the value of the boat has depreciated by the end of the second year after Pam bought the boat. So what we would be doing is 0.85 times 0.85. Okay, so 0.85 times 0.85 for 0.7225. Now this is 72.25%, but what this question is asking is work out the total percentage by which the value of the boat has depreciated. So from 100%, how much has this changed? And our answer is 27.75%. If you can give an exact value, you always should give an exact value. 0.75 is not that much of a big deal. So rather than rounding anything, I would just leave this as 27.75%. Okay? Okay, on to question 7. A cylinder is placed on the ground. The height of the cylinder is 18 centimeters, and the force exerted by the cylinder on the ground is 72 newtons. The pressure on the ground due to the cylinder is 1.4 newtons per centimeter squared. So, work out the volume of the cylinder. Give your answer correct to 3 significant figures. So, let's put in all the information that we have. So I know pressure, which is 1.4, equals force. It says the force exerted by the cylinder is 72 newtons over area. Okay, so if I rearrange this, multiply through by area, divide by 1.4, I'll have 72 over 1.4 equals the area. So if I do 72 divided by 1.4, we get, oh, this really horrible number, but we'll keep it stored in the calculator, 51.4285571, recurring between 4 and 1. Not the nicest, but we'll see what we can do with that afterwards. Okay, now from this point, actually, I don't really need to do much more. So this is the area down here. Now to work out the volume of the cylinder, we just take the cross section, which is that area already, and multiply through by the height. So the volume is just going to be this number, 51.4285571 recurring times 18. Okay, so times 18, and we need this to 3 significant figures, so I'm going to give it to more first, 925.714285, again recurring around the 5 and the 7, and to 3 significant figures, this is 926. Okay, on to question 8. Write 0.00089 in standard form. So a number between 1 and 10, 8.9. And how many has that decimal moved? 1, 2, 3, 4, 5. So we'll times 10 to the power of 5, but it won't be positive 5 because this is a smaller number. It has to be minus 5. And then next, 8.34, and I'm just going to throw in a bunch of zeros after this, times 10 to the power of 4. This decimal is going to move 1, 2, 3, 4 places until we're here. So that's 8, 3, 4, and 2 zeros, and I'll put a comma after that 4 just so it's crystal clear. On to question 9. 8 times 4t to the 0. Simplify. So I know that anything to the power of 0 is just 1. So 4t to the power of 0 is 1. So 8 times 1 is 8. Okay. And find the value of p, x to the 6 divided by x to the minus 5. Well, when I divide powers, I subtract them. So this is x to the power of 6 minus minus 5. So it's taking away a negative, so it's going to be x to the power of 11. So x to the p is x to the 11, and therefore p is 11. And finally, simplify fully. When I've got a power outside, it's important to remember that that power is affecting every single term. So it will multiply those powers here, and if we think about 2 to the 1, this is going to become 2 cubed, k to the 6, m to the 12. But I wouldn't leave it as 2 cubed, I'd leave it as 8, k to the 6, m to the power of 12. Okay. On to question 10. So this is where the questions start becoming a little bit more problem solving. Two circles, C1 and C2, are drawn on a centimetre grid with a scale of 1 centimetre for 1 unit on each axis. The centre of circle C1 is at the coordinates with -1, 3, so let's think about this for a second. -1, 3 might be around about here. And the centre of... and it has a radius of 13 centimetres. And the centre of circle 2 is at the point with coordinates 7, 18. So somewhere like this, so 7, 18. Work out the distance between these two centres. So this is the distance we're trying to work out. Now what I can do is I can think about this as a right-angled triangle. So we're going from -1 to 7, so that's a distance of 8, and we're going from 3 up to 18, so that's a distance of 15. So I can use Pythagoras' theorem to work out that distance going from C1 to C2. So the distance is going to be the square root of 8 squared plus 15 squared. So let's type that in. 8 squared plus 15 squared is 17. So this is going to be 17 centimetres. If you're not sure where this came from, let's call this distance d. Well, in fact, this is our hypotenuse, so let's call it h. And now we can say h squared is going to equal 8 squared plus 15 squared, so h will be the square root of all of that. One of the many applications of Pythagoras' theorem, finding the distance between 2 points. Explain why C1 intersects circle C2. So let's think about this. If this distance is 17 and C2 has a radius of 6, okay, and so this is got a distance of 6, and C1 has a radius of 13, then from this centre it will actually overlap, because 13, I mean, if we've already gone 6 along from 17, I've only got 11 left, haven't I? So if the radius is 13, of course this will overlap. So, explain why C1 intersects C2, because 17 is less than the sum of the radii. I'll just put in brackets 6 plus 13. So 17 is less than 19, so therefore overlap. Okay. And on to question 11. Factorise 9x squared minus 4y squared. Okay, so this is one of our special cases of factorising quadratics. We've got one square number, take away another square number. 9 is a square number, x squared is a square number. 4 is a square number, y squared is a square number. So this is the difference of two squares. So it's going to look like two brackets. In fact, I'll put these straight in to my answer. And I'll put the square root of 9x squared. So the square root of 9 is 3. The square root of x squared is x at the front of each. One will be plus, one will be minus. That's why it's the difference of two squares. And, well, this is why it's the difference of two squares, because we're subtracting two square things, and the square root of 4 is 2, and the square root of y squared is y. Okay, if you aren't 100% sure with these, remember you can always expand these out afterwards. But essentially what we'll get is 3x times 3x, which is 9x squared, 3x minus 2y, which is minus 6xy, but then we'll get plus 6xy from this expansion, and finally minus, because a plus times a minus, 4 from the 2 times 2, y squared, giving us 9x squared minus 4y squared. And part B, 7/8 minus x plus 3 over 4x. Now, the first thing I notice is this minus. I've got to be very careful about that minus, okay, as I look to carry on with this question. So the first thing I'm going to do is try and find a common denominator. So I think if I multiply this left-hand fraction by 2, or sorry, no, by x, so this is over 8x, and I multiply the right-hand fraction by 2, they will both have a common denominator of 8x. So the left-hand fraction I've multiplied by x on the bottom, so I need to multiply that on the top by x as well. And this right-hand fraction I've multiplied by 2, so this is going to be 2x plus 3. And actually I'll leave it like this, so that it's reminding me to expand it. Now when I combine this into one fraction, 7x minus 2 brackets x plus 3, all over 8x, it's again really important to remember this is minus 2, so everything needs to get affected by that negative. So this is going to be 7x minus 2x, and then minus 6 over 8x, leaving me with 5x minus 6 over 8x. So that will be my answer, 5x minus 6 all over 8x. Okay, on to question 12. Okay, tree diagrams, and Rudolph goes to the gym. The probability that he will use the treadmill is 0.8. Okay, let's start filling this in. So using the treadmill, 0.8, and therefore 0.2 that he doesn't. When he uses the treadmill, the probability that he will use the cross trainer is 0.3. So if he uses the treadmill, the probability he uses the cross trainer is 0.3, meaning this must be 0.7. When he does not use the treadmill, okay, does not use the treadmill, the probability he will use the cross trainer is 0.6. Okay, so now this becomes 0.6, meaning that this probability is 0.4. Complete the probability tree diagram for this information. Well, I thought I've just done it. There we go. You can put the probabilities at the end, and we can do that by multiplying along, so 0.08, 0.12, 0.56, and 0.24, and you can add those all up and make sure they sum to 1, but they do. Okay. Work out the probability that Rudolph uses both the treadmill and the cross trainer. So that's going to be just this top branch, this probability, 0.24. I'm just going to show my working here as well. 0.8 times 0.3 equals 0.24. Okay. On to question 13. Antoine is going on holiday. He makes 3 separate payments to cover the total cost of his holiday. The following table shows how much money Antoine pays to the holiday company. So, we have 3/8 of the total cost in payment 1, 45% payment 2, and payment 3 is $406. Work out how much Antoine has to pay the payment 2. Okay, so I guess what we need to work out is what percentage or what fraction, what proportion payment 3 is. So if I have 3/8, add 45%, so that's 45 out of 100. Let's work out what that is. So 3 over 8, add 45 over 100 is 33 over 40. Meaning that this must be 7 over 40. Okay, so let's say the total is x, so x times 7 over 40 must equal $406. And again, we can work out what the total is by doing 406 divided by 7/40. Okay, so 406 divided by 7/40 gives me a total of 2,320. Now, if I'm looking to work out the amount for payment 2, I just need to work out 45% of this. So payment 2 is going to be 2,320 times 0.45 for 45%. So times 0.45, and we get 1044. So that's going to go in here. Okay. On to question 14. So the function f is defined as f takes x to 2x over x minus 6. Find f of 10. So this is where I am inputting 10 into this function. So it becomes 2 times 10 over 10 minus 6. So that's 20 over 4, 5. Okay. And question 14b, this is where some people forgot their functions. This notation means inverse function. It's nothing to do with timesing by -1. It's where we first write out y equals, instead of f of x, y equals 2x over x minus 6, and we try and change the subject essentially. So what I'm going to do is multiply through, so y brackets x minus 6 equals 2x. Oops. And if I expand this, we have yx minus 6y equals 2x. Now, if I'm trying to make x the subject, I need to group all of my x's over onto the same side. So I'm going to subtract 2x and I'm going to add 6y as well. So yx minus 2x equals 6y. And because I've got multiple x's appearing, I now have to factorize. So x into y minus 2 will equal 6y, and therefore x is going to be 6y over y minus 2. Now, if this was asking for my inverse function in terms of y, this would be the answer, but it's asking for it in terms of x. So often what happens, and whenever I run out of space, I just draw a line down the middle and finish this off. We're going to flip it so that it's y equals 6x over x minus 2. So the x's and the y's have just changed position. So inverse function of f of x is 6x over x minus 2. And some people got similar solutions to this. They might have got minus 6x over 2 minus x, and that's also okay. It's just the same as timesing top and bottom by -1. Okay. On to question 15. Abraham is going to play a computer game. He can win the game, draw the game, or lose the game. For any game that Abraham plays, the probability that he wins is 0.3, the probability that he draws the game is 0.5, and the probability that he loses the game is 0.2. When Abraham wins a game, he scores 10 points. When he draws the game, he scores 0 points, and when he loses the game, he scores -5 points. So he plays 3 games, and the points he scores in each of the 3 games is added together to get his total score. Work out the probability that when he has played 3 games, his total points is 0, basically. Okay, so the most obvious one is that he gets 0 points every single time. So that's going to be the probability of him drawing the first game, drawing the second game, and drawing the third game. Okay? But there are other ways he can do this as well. If he wins the first game and then loses the second 2, that +10 and those -5s are going to cancel each other out. So if he wins and then loses, he will also get 0. And a lot of people stop here. Now, there are a couple of ways you could do this. You could draw out a tree diagram, which would be 3 branches, and then another 3 for each of those. And then for each of those, you'd have another 3, which seems like far too much branch work for me. So I'm just going to think about the routes that possibly happen. So the probability of drawing is going to basically be along the branches. It's going to be the probability of a draw. It's going to be 0.5, and then 0.5 again, and then 0.5 again. The probability of winning and then losing twice is going to be winning 0.3, losing 0.2, and then losing again. But this isn't the only way that we can get 1 win and 2 losses. Again, if you think about the tree diagram, you could win, lose, lose, or we could lose first, win, and lose, or you could lose twice in a row and then win. So we have 2 other routes of actually taking this. We have the probability of a loss, win, then a loss, or the probability of a loss, loss, and then a win. Either way, these are actually the same probabilities, just in a slightly different order. 0.2 times 0.3 times 0.2, and 0.2 times 0.2 times 0.3. So 0.5 times 0.5 times 0.5 is 0.5 cubed, 1/8, or 0.125. I'm going to keep these as decimals because the original probability was in decimals. We have 0.3 times 0.2 times 0.2, which is 0.012. And because these are basically the same calculation, just in a slightly different order, these are also going to be the same probability. And if I add all of those up together, so in fact what I'm going to do, I'm just going to times this by 3 just for ease of access, so 0.036, and then add 0.125, we get 0.161. Because that's what we need to do. We need to add up all the outcomes that gain us this final outcome of 0 points. So 0.161. Okay. On to question 16. Now this was probably the worst answered question on the paper. Okay. There's 2 things going on here. It's a surds question, so square roots and things, and it's a show that question. Show that. Now whenever we've got a show that question and it looks like an equation, we need to pretend we haven't seen part of this. Okay, I'm going to pretend I haven't seen that side. This is like in a textbook going to the back of the book and checking you've got the correct answer. Okay, so I'm starting off with the left hand side and saying that it equals 12 over root 2 minus 1 minus root 2 to the power of 5. Okay, and if you're worried about the space here, remember, you can just draw a line down the middle to confine you to work in one column, and you can always go over to the right hand side afterwards. So, now whenever I see this kind of surd, where it's a fraction, what they're always looking for you to do is to rationalize it. So I'm thinking 12 over root 2, in fact, equals 12 over root 2 minus 1. And to rationalize a surd like this, we need to times top and bottom by the complement of this, which is root 2 plus 1. Think difference of 2 squares, root 2 plus 1. Okay, minus, and I'm just going to start working on this one as well. This is, let's think about root 2 squared times root 2 squared times root 2 to the 1. That's how we can break up to the power of 5 a little bit here. Okay, well you could just type it in on your calculator, but this is how I like to think about it. Yeah, in fact it doesn't even let you simplify it that much there. Okay, so let's rationalize. So we've got on the top 12 root 2 plus 1 And on the bottom, we're going to have root 2 times root 2 for just 2. We'll have root 2 times plus 1 for plus root 2. We'll have minus 1 times root 2 for minus root 2. That's the whole point of doing this. Difference of two squares to cancel that out. And minus 1 times 1 for minus 1. Minus. Now, root 2 squared. The reason I put it into squared is because I know that the square root and the squared will cancel out. So it's going to be 2 times 2 times root 2. This root 2 left here. So this becomes 2, this becomes 2, and this becomes just root 2. Okay? So let's neaten up the top of this. 12 times root 2 is 12 root 2 plus 12. 12 times 1. And then the plus root 2 and the minus root 2 will cancel out, leaving it just 2 minus 1, which is just 1. Minus 2 times 2 is 4, root 2. Okay, so I've got 12 root 2 plus 12 minus 4 root 2 as a final solution. But I can go a little bit further. I can combine 12 root 2 and minus 4 root 2 to have 8 root 2 plus 12. Now, I'm happy with this as a final answer, but if I go back to the question, it wants me to end up with 2 root 32 plus 12. Now I've got my plus 12, but I don't have 2 root 32. So I'm going to now carry on, and I'm thinking, I don't want 8 there, I want 2. So I'm going to think about this as 2 times 4 instead. Root 2 plus 12. In fact, I stopped writing the equals, didn't I? Let's keep that equals coming, so we can see the evolution. And 4 is root 16. So this is going to be 2 times root 16 times root 2 plus 12. And now we can finally get, in fact, I might just get rid of this final bit because we're basically there now. 2 root 32 plus 12, which equals that right-hand side. Okay? Yeah. Okay, we are well and truly into the latter half of this paper now. Let's go on to question 17. Now, as soon as I see this equation, I know what kind of question this is. Anything that starts with an s equals, and it's always in terms of t, is going to be some form of differentiation question, where we're going from displacement, and then we can differentiate to get velocity, and we might even need to differentiate one more time to get acceleration. So let's have a read of this question and see what it's looking for us to do. A particle P moves along a straight line. The fixed point O lies on this line. The displacement of P from O at time t, where t is greater than or equal to 1, is s meters, where s equals 4t squared plus 125 over t. The velocity of P at time t seconds, where t is greater than or equal to 1, is v meters per second. Work out the distance of P from O at the instant when v equals 0. So all we're going to do is differentiate once to get velocity and set it equal to 0. I think it's important to know that the distance of P from O at the instant when v equals 0. So the displacement of P from O is given by this. So we need to work out what t is. So the first thing I need to do is rewrite s in a way that can be differentiated. Now 4t squared can be differentiated. 125 over t I'm going to rewrite as 125 times t to the minus 1. We can think about 125t as 125 times 1 over t. And this is t to the minus 1. Okay. So, on to differentiation. So ds by dt, which is going to equal v, times by the power, so 8, and then take 1 away from the power, 8t. And then apply the same thing again. So times by the power, so 125 will become minus 125, and this will become t to the minus 2. So v is 8t minus 125, and again you can think about this as times 1 over t squared if you'd like, t to the minus 2, or 8t minus 125 over t squared. Now we're looking to work out what the value of t is when v equals 0. So instead of saying v equals, I'm going to say 0 equals. And now I will add 125 over t squared to both sides. So I've got 125 over t squared equals 8t. And I will multiply through by t squared. So 125 will equal 8t cubed. And now I'll divide by 8, so 125 over 8 equals t cubed. Now I can cube root both sides to find t equals, now the cube root of 125 is 5, cube root of 8 is 2. So t is going to be, I guess you could say that's just 2.5. And so all we need to do now, and again I'm going to draw my line down the middle, is substitute this value into my original equation. So s is going to equal 4 times 5 over 2 squared plus 125 over 5 over 2. Okay, so let's type that in, 4 brackets, and I'll just put 2.5 in because it's easier to type, squared plus 125 over 2.5. Oh, and that's a very nice number indeed, 75. That gives me a lot of confidence that this is correct, 75 meters. Okay, on to question 18. Okay, we've got a triangle here. There's no right angles involved, which to me is screaming, let's use a bunch of trig formulae. Now, at the front of your paper, this is where it pays to know that what you get given. So on the trig section, we are given all of these really nice formulae here. Okay, I don't know why it's disappearing, but yeah, all of these nice formulae here. Okay, I won't continually scroll back up to use these, but I will quote them when we do the question. Okay. Okay. Right, on to question 18. Here we are. So, we are trying to find out the value of x. Now, if I'm thinking about using the sine rule, I need 2 pairs of opposite sides and angles. Now I've got 1 pair of opposite side and angle, but then my only other angle is this one here, and I don't have this side. So I still want to use the sine rule to get this one, but actually what I think I might do first is work out what this side is. So I can use say that I've got all 3 sides and 1 angle, which is where I'm going to use the cosine rule. So this is where I can say the angle on, or the side on its own, will be opposite the angle here. So let's call this y. I'm not going to call it x because x is the angle. So y squared equals 9.7 squared plus 12.3 squared minus 2 times 9.7 times 12.3 times cos of 115. Okay, so this is a squared equals b squared plus c squared minus 2bc cos a. I know this is b here, but as long as this side is opposite this angle, this formula operates successfully. Okay, so I'm just going to type this in now. So 9.7 squared add 12.3 squared minus 2 times 9.7 times 12.3 times cos 115 equals this very large number here, 346. So now I need to square root that, and I get 18.607. So y squared, let's actually use the full thing, equals 346.225 dot 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 dot. So y is going to be 18.6 dot 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 dot, and that's just a 3SF. And I will store this by hitting the STO on my calculator and picking a letter. I'm going to pick A, so I'll press that button next, and my answer has been stored to A if I need to use it again. And I'll just make a little note to myself that it's stored under A. So now I can apply the sine rule, so two pairs of opposite sides, and if I'm trying to find the angle, then we should put the angles on top. So sine x over its opposite side, so 9.7, will equal sine of 115 over its side. So that was this 18.6 dot dot dot, but I'll use A for this. So sine x will equal, let's times 3 by 9.7 times sine 115 over 18.6 dot 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 dot. So 9.7 times fraction sine 115 over, no, I stored this under alpha A, hit equals, and I've got 0.47. Okay, so what have I forgotten to do? This is what sine x equals, not what x is. So I need to do the inverse sine of this, of 0.4. So I'm just going to say this equals 0.472 dot 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 472 dot 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 dot, and I'm just going to do shift sine to get inverse sine, answer, and we've got 29 or 28.19431726 dot 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 dot, and it wants it to three significant figures. So this is 28.2 to 3SF. Okay, on to question 19. Okay, so this one has a lot of heavy algebra in it as well. OAB, that's this sector, is a sector S of a circle with centre O and radius r plus 7 meters. And angle AOB is 45 degrees. A circle C, so a different circle, has a radius r minus 2 meters, and the area of the sector S is twice the area of the circle C. So let's think about this. Find the value of r. So, and again, show all of your workings. So again, I'm going to draw a line down the middle just to give myself a little bit more space when I'm working all of this through. So the area of a sector is going to be the fraction of the overall sector. So 45 out of 360 times what would be the area of the whole circle. So that's pi r squared, and r here is r plus 7. So r plus 7 squared. That's the area of the sector, and we're told that the area of the sector is twice, so 2 times the area of the circle, so 2 times pi r minus 2 squared. In fact, actually, I'm not going to use that line. I think I'm going to need all the width I can, and we do get a bit more extra space down below if I need it. Okay, so let's just put this a bit more central and see what we have. Now 45 over 360, I think is just an eighth. Yes, it is. So let's rewrite this. And so an eighth times pi. Now, one thing it's really important to remember is when we're squaring something like this, we need to think about it as two separate brackets. Okay, same thing over here. R minus 2 squared is going to be r minus 2 times r minus 2. Otherwise, people forget that this minus 2 will times the r, and this minus 2 will times this r, and same thing over here with the 7s and the r's. So let's expand this. So this is r squared plus 7r plus 7r plus 49. And over here, we've got the 2 pi and the 1/8 pi. R squared minus 2r minus 2r plus 4. Okay, now one thing I'm going to do here is I'm going to divide both sides through by pi. Okay, it's not really needed here. So we've got an 1/8, and let's simplify this, r squared plus 14r plus 49 equals 2 r squared minus 4r plus 4. Okay. Now I'm going to, before I multiply out these brackets, I'm actually going to multiply through both sides by 8 because I don't like fractions here. So timesing through by 8 just leaves r squared plus 14r plus 49 on the left hand side, and 16 r squared minus 4r plus 4 on the right hand side. So now I'm going to expand the right hand side. So we have 16r squared minus 64r plus 64. Now I'm going to bring everything over, so r squared plus 14r plus 49 will still be there. Now I'm going to bring everything onto the right hand side, so minus r squared from both sides, 15r squared, minus 14 is going to be minus 78r, and minus 49 will be plus 15. Okay. Now for a second I thought 15 might go into everything, but not quite. 5 still, no, not 5, 3 still does. So if I divide both sides by 3, we end up with 5r squared. 78 divided by 3 is 26r, and we have a plus 5 here. And straight away actually I can see 5 times 5 is 25, and 1 times 1 will give me this other one I need. So this is going to come from brackets 5r and r, because r is prime, so it must come from these. Has to be negative, negative, because that's the only way to get a negative in a sum and a positive product. And to get 26, I want to do 5 times 5. So that's going to be that expansion, leaving the 1 here. So that's minus 25r minus another r to get that 26r here. But if you're not confident with that, you can still use the quadratic formula. So either 5r minus 1 equals 0, or r minus 5 equals 0. And from this, we get 5r equals 1, or r equals 5, and then r equals a fifth. So both are positive solutions that might work, or would they? So let's think about this in context. It says find the value of r, not values, so this would suggest that only one of them is a valid solution. And if I think about this for a second, if r is a fifth, r plus 7 is a valid sector, but if r is a fifth, r minus 2 will produce a negative radius for c. So I'm just going to say negative radius for c. So only viable value of r. So r equals 5 centimetres, I think. Is it in centimetres or metres? In fact, we don't need to do that because the unit is given outside of r, so r is just 5. Okay. Home stretch. On to question 20. So, okay, so looking at part I and part II, I can see that these are going to do with graphical transformations. So, the diagram shows a sketch of part of the curve with the equation y equals f of x. There is one maximum point on this curve, and the coordinates of this maximum point are s, t. Find in terms of s and t the coordinates of the maximum point on the curve with equation y equals f of x minus 2. So I always remember as if it's inside the brackets, it's going horizontally, but in the opposite direction than you might think. Whereas if it's outside, it goes vertically, and it does what you might expect it to do. And when we're adding or subtracting, it's a translation, whereas if we're multiplying, it's a stretch. So f of x minus 2 is going to be a horizontal, so horizontal translation because we're adding or subtracting, but because it's inside, it's actually going to go to the right 2. So in terms of s comma t, it's only going to affect your x value, which is your s value. So s will become s plus 2, and 2 will just stay the same. Whereas for part 2, where we are stretching vertically, this time the x-coordinate will stay the same, so this will be s, and your y-coordinate, so t, will be stretched out by a scale factor of 3, so it will be 3t. Okay. On to question 21, the histogram question. So, the histogram shows information about the total time m minutes taken by each child in a school to walk to school every day for 1 week. So the one thing that's missing here is the labelling of this axis. So that's the first thing I'm going to try and figure out. There are no children for whom the amount of minutes is more than 100 minutes, so there's no missing data. And there are 10 children for whom m is less than or equal to 20. So here, this area, and the thing you need to always remember with histograms is that area equals frequency. Okay, so this area represents 10 children. Okay, now we can do this in one of two ways. We can say that each 5 by 5 box represents 5, and you can work out future problems that way, or you could try and work out what the scale is on this side. I'm going to do it by working out what the scale is on this side. So I've got a width of 20. So what do I need to times 20 by? So 20 times my frequency density is going to give me a frequency of 10. Well, it needs to be a half, so 0.5. Okay? Frequency density is going to be 0.5. Okay, and that gives me my scale now. So this will be 1, this will be 1.5, 2, 2.5, 3, 4, and 5. Okay, and we're being asked to work out an estimate for the number of children for whom they were between 50, so that's here, and 80 here. Okay, so what I'm going to do in each of these groups, I'm going to do the frequency density times, so or the height, times the class width to work out the area inside. But you could have used that thing that I spoke about earlier, that each one of these represents 5 to give yourself a good go at working out what the total area is as well. Anyway, we have a width of 10 here, going from 50 to 60, and a height of 2.9. So 10 times 2.9 is going to be 29. We've got 29 in this band. Now going from 60, now this is 70 here, 80 here, so this looks like it's 75. So I've got a width of 15 and a height of 3.2. I think that is 48. So we've got 48 here. And finally, we've got a width of 5 times a height of 2 for 10. So 29 add 48 add 10 is 87. So the number of children in this group is approximately 87. Okay. On to question 22. A solid is made from a cone and a hemisphere. Okay, so this cone is here and the hemisphere half a sphere. The circular plane face of a hemisphere coincides with the circular base of the cone. The radius of the hemisphere and the radius of the circular base of the cone are both 20 centimeters, and the curved surface area of the cone is 580 pi centimeters squared. So that's just this sort of region around the outside, not the base. The volume of the solid is k pi centimeters cubed. Work out, now this is important, the exact value of k. So we don't want an approximate decimal, we want the exact value of k. And note that we've got pi in here as well, so we're expecting a final volume of both of these objects to be k pi something, okay? Or something times pi. So I'm going to start off with the cone. We were told that the curved surface area is 580 pi centimeters squared. So again, if you go back all the way to the start, to all of our formulae, we're given some nice things about the volume of a sphere. So 4/3 pi r cubed, okay? And the volume of a cone is 1/3 pi r squared h. But actually, we will use this, but we will also use the curved surface area of a cone is pi r l, okay? So let's get back to the question. Here we are. So the curved surface area is going to be pi r l. So 580, in fact, again, I'm going to give myself a bit more space and draw a line down the middle. Pi equals pi. Now instead of r, I'm going to put in times 20 times l. Now it's important, the diagram at the front, this is l, not the height. And that's going to be important because the formula for the volume does use height. So we'll have to work out height later. But if I divide by pi and if I divide by l, 580 pi over 20 pi, the pi's are going to cancel out, and essentially we have 58 over 2. So L is 29. But as I mentioned earlier, that's not going to help me when I want to work out the volume. I need h. So what I've got here is a little right angle triangle inside a cone. I've got to use Pythagoras' theorem again. So what we have is this sort of triangle, 29, 20. Okay, so what's h? So 20 squared plus h squared is going to be 29 squared. So h squared, which is not the hypotenuse, it's the height, but can be a bit confusing, it's going to be 29 squared minus 20 squared. So 29 squared minus 20 squared is 441, and I know my square roots. This means that h is 21. Okay, so my volume of my cone is going to be 1/3 pi r squared h. So this is going to be 1/3 times 20 squared times 21 times pi. So 20 squared times 21 equals 84. So this is going to be 8400 times 1/3, so over 3 pi. Okay. Now let's have a look at the hemisphere. The volume of the hemisphere is going to equal, a total sphere, so it's going to be half of the formula for a total sphere. So half of 4/3 pi r cubed. So this will be, the 2 and the 4 will cancel out, so 2 over 3 times 20 cubed times pi. So 2 times 20 cubed is 16,000. So this will be 16,000 over 3 pi. So the total is going to be 8400 over 3 pi plus 16,000 over 3 pi. So let's work that out. 8 400 plus 16,000 for 24400 over 3 pi. Now remember, it said it was k pi, so k is just going to be this fraction here, and we're going to leave it in exact form, 24400 over 3. Okay, on to question 23. Nearly there, 2 more to go. So, a polygon has n sides where n is greater than 5. So this means we're dealing with a polygon with more than 5 sides. When arranged in order of size, starting with the largest number, the sizes of the interior angles of the polygon in degrees are the terms of an arithmetic sequence. Here are the first 5 terms. So these are just the first 5. It doesn't mean that there are only 5. In fact, it said in the first statement that there are more than 5. So this is going to carry on going forever. Find the value of n and show clear algebraic working. So there are 2 things on the go here. Now we know that the sum of this series will be the sum of all interior angles. So I'm going to start by thinking of the sum of this sequence. So here we have a, the first term, is 177. And d is not 2, because it's decreasing, d is minus 2. So the sum to n, again, this is right at the front in the formula book, is n over 2, brackets 2a plus n minus 1d. So this is going to be the sum of all of these angles. And this should equal the sum of all the angles within this n-sided polygon, which is n minus 2 times 180. Okay, so let's put in the information where we can. So a is 177, so 2 times 177 is 354. Okay, and n minus 1d is going to be n minus 1 times minus 2. We still have, and I'm going to write it as a half n there, equals n minus 2 times 180. Okay, so yeah, just recapping, 2 different ways of thinking about the sum of all interior angles. It's going to be the sum of this interior sequence, and it's n minus 2 times 180. Okay, so let's try and neaten this up where I can. I'm going to times by 2, so I've got n outside, and this 180 is going to become 360, and I'll put it in front of my n minus 2. And then here, let's expand this, so this will be 354, and then minus 2n plus 2. Minus 1 times minus 2. So this leaves me with n, and then 356 minus 2n equals, let's expand this now, 360n minus 720. Okay, and then finally expanding this out, we're going to now have 356n minus 2n squared equals 360n minus 720. So there's a few things going on here, but essentially we've got n squared, we've got n's, and we've got single terms. We've got a quadratic. So I'm going to add 2n to this side, so that we've got 0 on this side. So 2n squared, then minus 356n from 360 will just be plus 4n, minus 720, leaving us with, if I divide everything by 2, n squared minus 2 or plus 2n minus 360 equals 0. So I'm looking for 2 things that factorize. One will be positive, one will be negative, which multiply to 360, but then when I add them together they make 2, so they have a difference of 2. And if I think about this for a little while, 18 times 20 will have that gap of 2. I want it to be plus 2, so this will be plus 20 minus 18. So n minus 18 equals 0, or n plus 20 equals 0, and therefore n equals 18, or n equals minus 20. Let's sense check this again. So n is the number of sides, can't be negative, okay, can't have negative number of sides, so that must mean n is 18. Okay, and on to our final question, question 24. Express each of a, b and c in terms of q, so that q plus 12x minus qx squared can be written in a minus b brackets x minus c squared. Now the key thing here is recognizing that this is the form of completing the square. We've got something times x plus or minus something squared plus c. If we wrote it in a different way, b or minus b, x minus c squared plus a, I think it might be easier to see that. Okay, so this is what I'm trying to get to. Okay, so what I'm going to do to start off with is rewrite this, our original thing, in the form of a quadratic. So minus q x squared plus 12x plus q. Now, I can't just say this equals 0. It's not an equation, it's an expression. So the first thing I need to do, and what I'm going to do is I'm just going to write down something like minus 2 here, or x squared plus 12x plus 2, for example, and think, what would I need to do to complete the square for this? Well, I can't complete the square if x squared is not a monic, so unless this isn't just x squared. So I need to factor out minus 2 from all of this bit. The plus 2 can wait till the end. So I would take out minus 2, and that would leave me with x squared plus that 12 over minus 2x. I know this can be simplified, but because I'm doing everything with algebra here, this was just to demonstrate the step that's going on. So minus q into x squared plus 12 over minus q x, and then plus q still to go. Now I can complete the square for this phase. So ignore everything else. Okay, and again, this is minus 6 if I was to simplify it. If I just wanted to complete the square here, this would be x, now this minus would make a minus here, it would be x minus 3, because we divide this by 2, squared, minus the square of this, so it would be minus 9, for example. So let's think about this. In fact, I might even take this negative out here so that it's a bit nicer to play with. So x squared minus 12 over q x plus q minus q. Okay. Oh yes, and let's just put all of this in so we can see what's going on if these were numerical. So complete the square. I need to half this. So let's put this in brackets. X minus, now a half of 12 over q, half of 12 is 6, so this is just going to be 6 over q, brackets, squared. Remember, there's no x in here because we are now completing the square. And then I subtract whatever this is squared. So that would be 36 over q squared. Okay, put my square brackets around that. I've still got my plus q on the outside. I've still got my minus q there. And now, again, I'll go back to the numbers. If I were to expand this out, I take this number in front of the square brackets, times it by the bracket, and then times it by the number. So again, if I were dealing with numbers, this should be minus 2 x minus 3 squared, minus 2 times this bracket, and then plus 18, where we would multiply those two together, and then I'd still have that plus 2 that I could simplify everything together with. So this will now be minus q times this bracket, so x minus 6 over q, squared. And now minus times a minus will be a plus. And this will be 36 over q squared times q. So actually, one of those q's would cancel, leaving just one q on the bottom. Yeah, essentially we've got minus q times 36 or minus 36 over q squared. The two minuses multiplied would make a plus, and this q would cancel with that too, leaving us just 36 over q. And we still have this q over here. So, have we answered the question? Well, actually we have. So, we have, if I rewrite this, 36 over q plus q minus q brackets x minus 6 over q squared. So b is just q. So c is going to be 6 over q. And a is actually this whole expression. Okay, we could write it as one fraction of 36 plus q, or 36q plus q, no, how would we do it? No, it would be 36 plus q squared all over q, but I would just leave it like this. So a, the number in front, 36 over q plus q. B is q, and c is 6 over q. Okay? The key thing here is recognizing that this is asking you to complete the square. I'm just going to remove now these numerical elements. Okay? There we go. And there's your paper.